Ecology and energy work together like two parts of a fine-tuned transmission. The sun provides us with rice, vegetables, and forests. These in turn become our food, materials for housing and building, and the fuels for cooking and heating. To grow, these plants use the carbon dioxide generated by living, breathing creatures and the various processes of life. Through photosynthesis, this CO2 is then discharged as oxygen into the atmosphere. Like humans, plants also breathe, but the oxygen released through photosynthesis is far greater than the CO2 discharged by breathing. The CO2 level in the atmosphere used to be balanced and fluctuated very little. It's a reciprocal process. Plants and other living creatures have long shared a give-and-take relationship. However, some time ago, due to the consumption of fossil fuels, the density of CO2 in the atmosphere began to rise. Now, the transmission gears of ecology and energy have gradually declined in performance. The sun's energy is clean and constant. Solar batteries are already used in many areas of our daily lives to provide electricity. But at night, without sunlight, they provide no power. And on days when the sky is covered in cloud, power generation is insufficient. However, in space, where clouds and night do not exist, power generation is both stable and constant. There is always an abundant source of sunlight. Space Solar Power Systems, SSPS, generate electric power on a geostationary orbit and transmit this power to an Earth facility. SSPS components are carried into space by reusable transport spacecraft. The SSPS will be built on the same orbit as the geostationary meteorological satellite Himawari, located above the equator at 36,000 kilometers. The SSPS consists of many large panels, one of which is the condenser that collects sunlight. The components, requiring several trips to deliver, are assembled automatically. Along the geostationary orbit, the sun always shines, except for the brief periods of eclipse during the spring and vernal equinoxes. In space, where there are no clouds, dust, or night, the SSPS collects considerable sunlight, which is then converted to energy. Energy generated in the geostationary orbit is converted into gentle laser beams and microwaves for safe transmission to facilities on the ground. Energy is necessary in our everyday life, and we need clean energy with no CO2 emissions. Automobiles are slowly changing as we move from fossil fuels such as gasoline to vehicles powered by fuel cells or electricity and which do not emit CO2. the electric power that supports our society must be clean as well. Whether it's spring, summer, winter, or fall, when it's night in Japan, SSPS can transmit clean electric power almost continuously. Solar space power systems research was first proposed in the United States in 1968. Shortly afterwards came the oil crisis. While concrete plans were begun to solve energy problems, financial problems ultimately prevented any success. However, in recent years, as awareness of global environmental issues has risen, it has again become a focus for countries around the world. In Japan, research began in the early 1990s. Now, SSPS research is ongoing in laboratories both in Japan and abroad. Our spaceship Earth might be called the planet of life. SSPS is technological space research created on Earth to protect its environment. Our precious Earth environment, where we make our home. Making use of the sun's ample natural energy, SSPS, space solar power systems, can supply clean, calm, and stable electric power.